On to 2.5. I'm going to give you a title in a second, but I kind of want to go over what we're basically doing. Okay? So what we're basically going to do is we're going to cover a little bit of logic using inequalities. Okay? And so we're going to cover what basically certain words mean in logic. Okay? And so I'm going to do a non-application real quick, and then we will apply it to real life. So this is going to be, we'll just call this, what is this called? I don't remember. Is that right? Venn diagram? Okay. I didn't leave a lot of room to put somebody there, so I'm going to turn it sideways. Put Sue there. I'm going to put Bob here. And I'm going to put Steve here. Okay, tempted to put names that I haven't had in class in a long time, but that doesn't always work. Okay, so I'm going to write a statement, and we'll see if we can figure out the answer to this. And don't say it out loud. Okay. Who plays band or football? Okay, and I want you to think about that and looking at this Venn diagram, this one being band and that one being football, see if you can answer the question. And kind of the focus we're focusing on is the logic of the statement, and more specifically this word, what it means in logic. And then I'm going to go over what logic is used in real life. Okay, who do we think? Who plays band or football? So Bob plays band or football, right? How about Sue? Does Sue play band or football?
Yeah.
How about Steve?
No.
Yeah. Because the word or means only one has to be true. Does Bob play band or football? He does band, so yes, he plays band. Does Sue play band or football? Well, she does both, so that would be a yes. And does Steve play band? No. And I know technically you don't play band, you play an instrument in the band, but that's not the point. I know Steve doesn't play band, but he does play football. So the word or, when you use it in a logic sense, basically means that only one has to be true for the whole thing to be true. Okay. I'm going to set another scenario, and this one's actually going to be more real life that matters. And we still haven't done a title yet. Okay, let's say that you are in the hospital. Here's my little hospital bed. Okay, and then you got this machine hooked up to you, right? Okay, and this machine has an alarm on it, right? You know, that usually has little things like that. And it goes beep, beep, like that a lot. Yeah, you've seen that one before? At least on TV? Okay, one of the things that it measures is blood pressure, or, you know, how many times your heart beats in a minute. You know, you have all kinds of monitors. So the programmer or the doctor, whoever sets the levels, might set something like this up. BP greater than 100. Is that a good thing? If your blood pressure gets over 100?
No.
Not if you're lying in a bed. It might be okay if you're exercising, but not if you're lying in your bed. So I might want that alarm to go off, right? If the blood pressure gets too high, I might want the alarm to go off, right? But what if your blood pressure is at 0? What happens? You are not very much alive. So I might want to set the alarm also to do this. So I might want the alarm to go off also if I get below 50. Okay? So this is a case where we want an or in real life, where we want the alarm only, we don't want it to go off all the time, do we? We want it only to go off if it's too high, or too low. And we use this a lot in medical situations where heart rate, blood pressure, even your sodium potassium content, your cholesterol, your iron, if you have too little iron in you, then what happens? Does anybody know? They call it anemic, right? What happens if you have too much iron in you? Well, you're not dead. You can have too much iron. You become Iron Man, right? That's how it works. Okay. You might have to look up what happens when you have too much iron. But you're supposed to have, when they do those blood tests, you're supposed to be in between two levels. And if you're in between two levels, you're fine. But if you get above it, it sets off an alarm, an alert. Okay, so that's another real life, in the medical field. Another one is, I'm not going to draw this very good, but let's see here. Yeah, it's not very good. There's supposed to be light switches. Okay. So, do you have any lights in your house that have two light switches?
Yeah.
Is it a hallway?
No, it's my room. No, it's my bedroom.
The bedroom? Well, if you're in bedroom, probably one controls a light and one controls a fan, right?
Yeah.
But I mean two light switches that control the same thing.
Yes.
Like in a hallway or stairs? And so the purpose of it is to do what? So you can turn on the light at one end and go to the other end and turn off the light?
Yeah, don't have to run up the stairs all stuff.
Okay. This is actually a little more complex than what we're doing. This light switch would actually be called this, and we're not going to go over that. We're only going to go over the word or today. Okay. But a lot of times in electronics and electricity, we do have two switches that control the same thing for convenience or for other reasons. The best example of an OR switch to me is I have a TV and I have a remote control of the TV. Is that the only way I can control that TV?
No.
How else can you control that TV?
The button on.
So you can do the TV or the remote or anything else? Some people saying Roku or phone. I use my phone mainly for the TV.
If your TV has like
Yeah, well, or a smart TV. There's different ways to do that. So you have a lot of switches for convenience, right? They both do the same thing. What happens if your TV remote breaks and your phone still works? Can you still control the TV in that situation?
yes.
So that's a nice thing to have an OR situation. Or you can have a Roku, like you said. All right, so this is all things that deal with this word OR. So our actual title is going to be Compound, Inequalities, and we're going to focus today on the word OR. We're going to, over the course of the year, we're going to only discuss 3 of the words. We're going to discuss or, and not. So right now we're going to do or, but we're just going to use compound inequalities. And honestly, this one is probably the closest to what we're going to use. We're not going to really do electronics. Okay? So let's go ahead and write a problem, and we'll see what we think about it and see how it works. Okay, I'm going to put the word or in between it. That's how you know it's an or situation. Okay, it looks kind of like 2 different problems, doesn't it? We're going to work it like 2 different problems. So go ahead and work them like 2 different problems, and then I'll teach you how to graph them. And actually, I want you to try to graph it yourself. And the nice thing is that I don't have to make them as hard as what we just took a test on. We can have 1 step, we can have 2 step. We're trying to get the concept of it, and then we're going to kind of move forward with that. All right, let's look at here. This one would be just what? Divide by 5?
Yeah.
Divide by 5, I get x is less than negative.
4.
Okay, that's easy enough. All right, let's look at this. Minus 6, I get what? Okay. Now we need to graph it. I'm going to give you a second to graph it real quick, and then I'll show you how to do that. And which one? I'm supposed to grab both on the same number line. On the same number line. Because we kind of want it to look like that hospital situation where we have an alarm. Okay, how would I graph this one? I just circle -4, right?
Yes.
And which way do I color?
Left.
Like this? Okay, how about this one? I'm going to circle, and what else do I do?
Dot.
And which way do I do the arrow?
Right.
Okay, this is what an OR graph is going to look like. Okay, let's see if we can figure out what this means. Let me use a different color, because that's very red and doesn't show up very good. Is 5 a solution? I want you to think about it before you say it out loud. So think about it right now. Is 5 a solution? And we can look at the graph and it tells us all the solutions. What do we think? Well, 5 would be right here, wouldn't it? Is that part of my graph?
Yes.
So it is a solution. So in this case, if I got a 5, the alarm would go off, wouldn't it? Okay. How about is 3 a solution? I mean, -3.
No.
No. Because it's in between the two.
It's right here. Would the alarm go off?
Yes.
Yeah,
No,
no.
it's not colored. That's where it's off. Only where it is colored is a solution. Okay, is -4 a solution?
Yes.
No.
Remember the circle. How about if -4 is not a solution? How about -4.1? Is that a solution?
Yes.
Yes.
Because that's just to the left of it, right? So that's how that works, right? So in this scenario, what you would want is a number here or a number here. Can it be in both? Can I have it be true for both of them in this case?
Yes.
Is there really a number that is going to be less than -4 and greater than -2?
It's not possible.
So that's not possible. So it's either going to be true here or it will be true here. But if it's in one of them, it is a solution. Okay, that's notes. And I'll give you